So this is page 2 of the study guide, and in this page we're going to start talking about extrema and what possible sketches could look like for our functions. So problem number 5 says list the possible number of extrema for each type of polynomial and sketch an example. All right, an 8th degree polynomial can have 7, 5, 3, or 1 extrema. So basically what I do, the quick way for me to do this is whatever the degree is, drop it by 1, and then in this case we're talking about odd numbers, so it's all the odd numbers below that original degree. So 7, 5, 3, 1, and that's all the possible extrema. So an 8th degree polynomial means we're talking about an even degree, which means our end behavior has to match. And so you can make it as simple as saying, you know what, I'm just going to do x to the 8th and make it look like that. That is absolutely a possible way that graph could look. You could also start going through and crossing the x-axis up to 8 x-intercepts, okay? Excuse me. All right, 3rd degree polynomial, drop the degree by 1. So now we're talking about 2, and we're now talking about even numbers below our degree. So 2 or 0. And yes, you can have no possible extrema. So the very simple 3rd degree polynomial, let's just go with a straightforward one, is this one. And this is actually the example of the 3rd degree polynomial that has no extrema. There is no relative minimum or maximum here. This is just a increasing function the whole way. All right, 12th degree polynomial. Drop the degree by 1. 11 is an odd number, so I want all of the odd numbers less than 12. So 11, 9, 7, 5, 3, and 1. 12th degree polynomial is an even degree poly, and so that means that your end behavior has to match. So let's go for the one that has, 12 x-intercepts here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's my 12th one. So all of these mountains and valleys, if we actually counted them out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the example that has 11 extrema. Okay, and there are ways to draw this graph that have 9, 7, 5, 3, or 1 extrema. Okay, all right, last one on the extrema, and the example is a 9th degree polynomial. I count it back by 1, so that's going to be 8, and I want all of the even numbers less than 9. So 8, 6, 4, 2, and yes, 0 is actually considered an even number. So let's see what we've got here. Let's do a 9th degree polynomial. This means our end behavior has to be mismatched, so it's not going to match. So let's do 1, 2, 3, 4, 6, 7, 8, and there's my 9. And this example has 1, 2, 3, 4, 5, 6, 7, 8, 9 x-intercepts. Remember, the fundamental theorem of algebra says the degree has to have the same number of x-intercepts. And this would also have 8 extrema if you were to graph it out as this function. But again, there's other ways to draw these functions. Just make sure you understand if it's an even degree function, your end behavior needs to match, whether they're both going up or both down. A odd degree function, the end behavior is mismatched. So this is going to positive infinity, this is going to negative infinity. Okay. So let's see about problem number 6 here. All right, we are given a of x is equal to this expression. We're given b of x is equal to this expression. And c of x is equal to this little expression right here. And we are asked to find d of x, which if we look at what d of x is equal to, it's a of x times b of x times c of x. So this is just the product of our expressions, okay? And so don't get too weirded out about it. Let's see, d of x is equal to, well, a of x is 2x plus 1, b of x is negative 5x minus 3, and c of x is x minus 10. Now, one other thing to pay attention to is in the directions, it says to write this in standard form. So you absolutely are going to need to multiply this out. But remember, with multiplication, you only ever multiply two things together at once. So I'm going to multiply this first little expression times this second expression. So I'm going to distribute here 2x times negative 5x, so negative 10x squared. 2x times negative 3, negative 6x. Multiply 1 times negative 5x, so negative 5x, and 1 times negative 3 is negative 3. Now this whole thing still stays in parentheses because I'm eventually going to take this answer and still multiply it times x minus 10. All right, so I still want to have this. So d of x is equal to, now I'm going to combine like terms. And there we go. All right, so x minus 10. And now I'm going to distribute again. All right, so d of x is equal to, I'm going to take this first term times x, so negative 10x to the third. Let's see, positive 100x squared. I'm going to take negative 11x multiplied out, so negative 11x squared. Multiply here, we're going to have, what would that be, positive 110x. Let's see, negative 3 times x is negative 3x. Negative 3 times negative 10 is negative, positive 30. Let me fix my sign there. All right. So now I'm going to combine some like terms here. So d of x is equal to, there's nothing like to negative 10x cubed. Positive 100x squared minus 11x squared. So positive 89x squared. That should work. We've got positive 110 minus, positive 110x minus 3x. So plus 107x plus 30. All right, so that is, we found d of x and we wrote it in standard form. All right, let's move on to number 7 here. All right, so this time we're given, let's see, we're given a of x is equal to 4x plus 3. We're given b of x is equal to 3x squared minus 6x plus 2. And we're asked to find c of x, which is the product of a of x and b of x. Product just means to multiply. And of course, we need to write it in standard form. So let's see, c of x is equal to, well, a of x is 4x plus 3. And I'm going to multiply that times b of x, which is 3x squared minus 6x plus 2. And we're going to distribute. All right, so 4x times 3x squared. So this is c of x again. Let's see, 12x cubed. Distribute some more, minus 24x squared. Distribute some more, so plus 8x. Distribute here, plus 9x squared. Minus 18x plus 6. So c of x is equal to 12x cubed. Let's see, minus 24x plus 9x squared. I believe that would be negative 15x squared. I want to do a quick double check. Negative 24. Let's see, negative 24 plus 9. It is negative 15. All right, still working right. Positive 8 with a negative 18. Those are both single x terms, so minus 10x and plus 6. So standard form means you multiply it out and you look for like terms. So combine your like terms. Now the reason I did this in highlighter is when I wrote the box around this, it kind of obliterated my double bar here. So I wanted to make sure you didn't think that this 8x was like to the x squared terms. All right, let's see what else we've got here. All right, problem number 8. Analyze the two functions. Circle the polynomial function. So we've got m of x over here, or k of x over here, which has the greater number of possible extrema. Okay, now the easy one here is going to be, if we look at k of x, we're given the graph. So we have one extrema here, we have two extrema, so I'm literally going to mark 2 extrema, okay? Now separately, we have part A here. A quintic function. So quintic function is 5th degree. okay, with a less than 0. So your a value is negative, okay, and 5 distinct real roots. That means this thing has 5 x-intercepts. It's going to cross the x-axis 5 times. So if I were to graph this, now because a is negative, a is less than 0, I actually want to start up top here, and I'm going to have a decreasing function overall. So I'm going to start up here, and I want 5 x-intercepts. So hold on. I'm just trying to draw a line here. So 1, 2, 3, 4. There's my 5th one. Okay. So how many extrema does that graph have? Well, here's a valley, here's a mountain, a valley, a mountain. 1, 2, 3, 4 extrema. Okay. And I'm going to double check. Did I want the greater number of extrema? I did want the greater number of extrema. So circle the function. It's this one. All right. And yes, make the circle ridiculous without actually circling both of them, because, well, that's not going to help. All right, last problem on this page, which is problem number 9 here. Again, we've got 2 functions and we are comparing them. We've got c of x over here and we've got w of x, and we're looking for a greater relative maximum. So if we look at this graph right here, we have this maximum point right here, okay? I'm going to zoom in here. So here's my maximum point, and this is at y equals -1. All right, so I've got a maximum. Now I want to take a look at part B here. Got a quartic function, so quartic is 4th degree. A is greater than 0, so that means this is positive. And 4 distinct real roots. So we've got 4 x-intercepts. Okay, so I'm going to draw this. So if a is positive and we have a 4th degree function, my end behavior is going to point up on both sides. So I'm going to start up here, 1, 2, 3, here's my 4 x-intercepts, right? 1, 2, 3, 4 of them. Now, I have no idea where this high point is, but I guarantee you it has to be above the x-axis, which means I'm going to mark this as y is a positive value. I don't know what positive value it is. No clue, okay? Could be a lot of different things. But if I'm looking for a greater relative maximum, a positive number is always going to be greater than a negative, okay? So this is the function that has the greater relative maximum. So that's the function w of x. All right, on that note, I'm going to go ahead and close this video out. As always, if you have questions or concerns,